I hope you all are doing good. Uh, Let us get started from where we have discontinued. So we have started with multimedia communication technique, which is finally a subject for BENTC in Solapur University, Solapur. Earlier, we have gone through the revision part of unit number 1, unit 2, unit 3 and unit up till unit 2, unit 3. Now let us continue with the revision part of unit number 4. The unit 4 is all about audio and video recording systems. So let us understand what kind of audio and video recording systems we are supposed to study here. Before we get started with the actual syllabus, the content, which I'll just show it to you. All the contents here are the digital sound recording. The types are CD, DVD player, MP3 player, Blu-ray DVD player, ITU-T G, which is the compression standard for audio signal, and multi-channel Dolby 5.1 sound system in DTV. So basically, if you go through the entire syllabus, you will find that all the kinds of recording which has been done here is digital recording. So whatever the sound signal which get recorded here, all the types which are specified here, all are the digital recording types only. But before we get started with the digital recording, let us quickly go through how earlier days, like ever since the evolution of television took place, evolution in the audio recording took place. So, what other types of audio recording systems were into the market since say 1960s also. Quickly, we'll revise so that we can utilize the basic information which has been or basic working principle of those types. So earlier recording types, the first one which was suggested was the conventional disc recording, where you can see the gramophone kind of recording system, where there used to be a very huge size of disc, which is generally a lacquer coated on a polycarbonate material, on which a certain layer of the material is laid, lacquer coating is done, which is similar kind of wax kind of material, and whatever the recording is to be done, the recording is done on in the form of grooves on those magnetic disc, so on this conventional disc. Here you can see here all the picture that is in front of you is of the needle which is rested on the grooves, which are spiral grooves recorded in circular fashion. So all the audio signal information is recorded in the form of grooves, and when we are trying to play these audio signals which has been recorded, we need a unit like this. This is for playback unit, and the earlier this one was for the recording unit. Now here what the entire scenario, or how the block diagram works. And now audio signal, we all know, is nothing but the electric form of an sound signal, and sound here we know is whatever the pressure vibrations available. Like whenever we speak, if you just hold your hand in a reverse way, you will observe that whenever you speak, there are certain vibrations, there are certain pressure exerted from your mouth, or rather on through the vocal cords, and whatever the word that you utter has a specific pressure signal allotted to that word. So every signal that we speak, or every word that we speak, we have a pressure variation. So we need to convert those pressure variations into an audio signal, which is nothing but an electrical form of signal. So for that we use a microphone. Now there is a diaphragm placed in a microphone, so that whatever we speak, pressure variations will get converted into an electrical signal. When the diaphragm moves, which is placed in a magnetic field, obviously it will result into certain electrical signal. Now whatever signal that we'll get, we'll first give it to a pre-amplifier, followed by pre-emphasis, where we need to give justification to all the frequency range, then followed by driver or power amplifier. Then there will be a recording unit like this, and then the disc is mounted on a a turntable which is driven by a motor. So all in all, this is how the system works, that whatever you utter, whatever you speak will be converted into an electrical signal, that is audio signal. It will be processed, amplified and given to a recording unit, and then depending upon the vibrations of a needle, those audio signals will be recorded in the form of varying dimensions of the grooves. And here the dimension of the groove changes as your audio signal get changed. So in short, your voice is recorded in the form of varying dimension grooves. Now how to retrieve the original sound? Now there you need similar kind of assembly, where at a recording unit similar kind of needle will be placed on the recorded unit. Whenever the needle pass through the grooved area of the disc, obviously that needle will vibrate, and those vibrations will get again getting converted into an electrical signal, and that electrical signal will be your audio signal, which after amplification and proper processing will be given to and sound, and then sound box will give you a loudspeaker will give you and electrical signal converted into pressure variations again, which then you can hear, like whatever you have recorded you can hear the similar kind of thing, because it has gone through several kind of processing stages. And that is how we used to record the sound. Now obviously there are lot many changes happen to the signal, and that is why this kind of mechanism that we have, too many mechanical movement parts, too many wear and tear, the size of the disc is very high, so a bulky assembly, and because of which this kind of mechanism was is not continued. Rather we have switched back from this to the next type of recording. That the kind of recording here we call it as a magnetic recording, which came after the conventional recording type. Now what has happened in an magnetic recording? Now here is the basic working principle of how that magnetic recording work. Now magnetic recording depend upon a phenomena where certain magnetic materials are there, to which if you magnetize them once, they will permanently keep that magnetism, or they will retain that magnetism permanently. The magnetism will not be loosened. Like you would have gone through an hysteresis curve, and you have observed that once you keep on increasing the current on one side, the magnetism will keep on increasing, the magnetic field strength will keep on increasing, the density will keep on increasing. Once you try to reduce the current, then there will be certain amount of residual fluxes which will still be present in that magnetic material. So even though you make the current equal to zero, those residual fluxes will still remain over there. So such kind of property only we use, that once it is magnetized for a longer run, rather for an permanently it will retain that magnetism, so that whenever you want to record a sound signal, what you do is you convert that sound signal into an audio signal. Obviously process will remain same, that apply or give that audio signal to apply that sound signal to an microphone. Obviously with the help of microphone it will get converted into an audio signal, process that audio signal, and then pass it to assembly, where that electrical signal will be wound on a solenoid kind of structure, where the electrical signal, that is audio signal, will get converted into an varying magnetic field. And that magnetic field, once passed through a magnetic tape, that magnetic tape will retain the magnetism, it will get magnetized. So in short, to conclude this, whatever the sound variations are there, that will result into variation in audio signal, and those variations will result into uh, a tiny magnets which are available on the magnetic tape, and that is how recording has been done. And then similar kind of process will happen for retrieving the signal which has been recorded, that varying magnetic tape, that means a different tiny magnets once pass on through an air gap, which is for an solenoid kind of structure where certain coil is been placed. So d phi by dt will took place because the magnetic this magnetic tape which is recorded will have certain amount of tiny magnets, and those tiny magnets will move through that air gap. So obviously that will result into d phi by dt, and whenever d phi by dt is there, according to the Faraday's law of electromagnetic induction, there will result into current. Now that current will depending upon how the variations are, and which is nothing but how we have recorded the sound signal. So similar kind of signal which we have recorded, we will get at the time of reproduction of that particular signal, and that is how this magnetic recording works. Now obviously here also there are too many movement mechanical parts where the sensor is still in contact with the material where the audio signal is recorded or the sound signal is recorded, and that is why this is also now not into the picture available. So next type that we moved, like both these type here, what we have seen is the audio signal which is remain in the same form of analog signal, like how we get it, like once those sound signal, that is pressure variations, converted into an electrical signal, the obvious form is in analog, and this it continued to be in the analog domain only. Now what next type that I am suggesting here is nothing but the digital sound. What does this mean? That whatever the sound signal that we receive, obviously that won't be into a digital form directly. Whatever the sound signal that we will be getting, obviously basic principle starts with whatever sound is available, it is pressure variations, you have to convert that into an audio signal, and for that you have an option of using a microphone, and whenever you use a microphone, obviously it will result into an analog signal. So what do you understand by digital sound? It is nothing but the sound information or an audio signal information which is available in analog domain, you have converted that into an digital domain. So all the audio information which is available in the form of ones and zeros is nothing but your digital sound, and this is how we digitize an audio signal, the similar kind of process that we used for analog to digital conversion. So obviously what we will be doing is we'll be going for a sampling and holding, and then followed by an quantization level. So here how your quality of audio signal depend upon how you go for sampling of your analog audio signal. So if you go for higher sampling rate, obviously the quality of audio signal will enhance. Again you need to go for better quantization level, so that again the quality will improve a lot, and you can easily convert back that signal into again back to the analog domain when you need to feed it to an loudspeaker or a sound signal. So again you need to convert that recorded signal into analog domain, because to a loudspeaker when you need to apply a signal, that has to be an analog domain only. So you need to have a conversion of digital to analog again. So to get that conversion, you need to use higher sampling rate as well as the higher quantization levels as well. Now obviously when we are going for that, we need to use a PCM speech kind of thing. Here you can easily see, so as the analog signal amplitude value changes accordingly, you need to ensure that your segmentation for the digital value should get changed accordingly. Now this is how a CD player works. This is how a basic working principle of how the sound is recorded on a compact disc and how it is retrieved back. Now here is the picture of an CD, and here it is an description of how a sound signal is, or rather how an audio signal is retrieved back from recorded compact disc. So what do we do in CD player for recording is we use a laser beam, and we use a polycarbonate disc on which a lacquer coating is, on which a coating of a photoresist material is laid. Whenever we we need to record a sound signal, we first convert that sound signal into an audio signal with the help of microphone. Then that audio signal will be converted into a digital signal, so now it will become a digital sound. Once that signal is digitized, it will have values of ones and zeros only, and those, with the help of those ones and zeros, we give it to a laser beam so that the laser beam can be made on and off. Now once the laser beam is directed or pointed towards the compact disc, and when the compact disc is rotating, when the laser beam is made on, it will strike that laser beam surface, which is coated by a photoresist material, and then there will be a formation of pit formed on a compact disc. When the laser beam get a signal 0, beam will be off, there will not be anything striking that the compact disc, and then a flat will be created, that nothing has happened, that there we call it as a, we refer it as an flat. So in short, whatever the sound signal is there, which is a digitized sound signal, that will get recorded on a compact disc in the form of ones and zeros, in the form of pits and flats. When we call it as a pit, where the laser, when the laser beam was on and it has struck the surface. So in short, your sound signal which you have just recorded is in the form of pits and flats on the compact disc surface. Now here is sample surface for the compact disc. Here you have several values of pits and flats. Now here, when we want to retrieve what signal that we have recorded, we need to count those pits and flats, or we need to measure or read those pits and flats. So what we do, we use another laser beam which is meant to focus on that compact disc when the compact disc is into the rotation, and we use a half silvered mirror or a prism structure here, where from this side the laser beam can pass and hit the CD surface, but while returning back from reflected back, when the signal laser beam is reflected back from the CD material, then it will not penetrate and go back to the laser beam assembly, rather it will be deflected towards this photodiode arrays. So this kind of structure that we use in a CD player, where once a beam is hit, it is focused, hit the CD surface. If it hit a flat, obviously flat will be a very reflective area, because we haven't earlier while recording this a laser beam didn't hit the disk surface, so it is more reflective, and once it hit the CD surface, its refractive index has reduced or gone to a very lower value. Because what we do is, once the recording is completed, we go for an aluminum coating of the surface, so that when flat is there, it will be coated properly as a reflective material, and when pit is there, there will be very low kind of reflection. So once the laser beam hit the surface, if it hit a flat, then there will be higher amount of reflection, and if it hit the pit, there will be very low amount of reflection. So that way we now have laser beam to focus on the surface, and once laser beam is returned back with the by analyzing that reflective index, now how much is the reflection back hit after the laser beam strikes the CD surface, we can judge whether it has came from a pit or it has came from a flat. So this way we can identify that whether the laser beam has hit a 0 on a CD surface or a 1 on the CD surface, and that way, with the help of photodiode assembly, photodiode array, we can get the values which are recorded on compact disc in the form of pits and flat. Those are nothing but the value of ones and zero. So in short, while reading what kind of data that we have stored, we can have the value in digital form, in the value in the form of ones and zeros. Once that ones and zero binary data is available, we can go for conversion of that into an analog form, and then we can retrieve the original audio signal and can be passed onto a loudspeaker. And this is how we work for a CD player, or this is how a CD player works. Whatever I have just told you, this is summarized in a block diagram way. This is a very big block diagram where the how the focusing and radial tracking with the help of servo motor has been done. This is how the assembly. This is the part we have just seen, and then after analog digital to analog conversion, audio amplifier, we give it to the proper channel. Now next part is how a CD differ than that of a DVD. So as far as the construction, the working principle, the size, the shape, nothing has changed. CD and DVD both in working in everything in every aspect is same, only with the difference that a DVD has a more storage capacity here. Now how a DVD can store with the same size, same physical size, as DVD can store higher amount of data as compared to CD, because when we ensure that laser beam strike the compact disc and there create a pit. So if the pit created there is of a smaller size, smaller dimension, obviously it can store more number of pits and more number of flats. So that way, by changing the wavelength of a laser beam, we can have more data to be stored on a compact disc, and that is nothing but the newer version of compact disc, that is DVD, which come with the size of 4.7 gigabyte if it is single sided single layer. It also come with three more variants. If it is single sided but double layer, the capacity almost get double, which is 7.95. that on a single side only, by changing the focus of a laser beam, we can have two number of layers where the recording can be carried out. Then we have third part, that double layer, double sided single layer on the surface of the this DVD disc. We can record on both the side, either bottom side as well as we can record on the top side, and that can be done for single layer. Then the capacity here is 8.75 GB, and if we go for recording on double side, both the side with double layer, the capacity has increased a lot up to 15.9 gigabytes. So this is how DVD comes with four different variant, and with obviously with higher data storage capacity. Like for CD it's around 700 MB, but for DVD, if we go for the basic, it comes up to 4.38 GB of data. So obviously DVD with higher storage, and with a change that the laser beam has changed into the wavelength. And the next wavelength, next is nothing but the Blu-ray. Now here also nothing has changed. Almost every aspect of CD, DVD and Blu-ray are same. Only the difference is the kind of wavelength of laser beam that we use. Now here you can have a very very close encounter how exactly they differ from each other. Now here we have comparison of CD for DVD as well as for Blu-ray. Now here you can see the dimension of laser beam has changed from 780 nanometer with lens aperture of 0.45. Here we use 650 nanometer. So obviously when the its wavelength has got changed, so obviously it can store it can form very tiny pits and flats, so higher amount of data. Also here you can see the difference that the distance between two tracks is also has reduced drastically, so that number of tracks for a DVD are way more than that of CD. And if you compare for Blu-ray disc, obviously it is way better than that of a DVD. So higher and higher amount of data we can store in a Blu-ray. Here the wavelength also used is 405 nanometer, and the distance between two tracks for CD it is 1.6 micrometer. For DVD it's 0.74 micrometer, and for Blu-ray its lowest is 0.3 micrometer. So with this comparison also you can understand how the capacity of Blu-ray disc is way higher than that of CD and DVD. Now what all that we have discussed, the how we can store the audio signal on different different discs, let it be CD, DVD or Blu-ray. But important point that we should not miss here is uh, we go for higher number of sampling rates and higher number of quantization level only for getting a higher quality or best quality audio signal. And if we go for that, if we go for higher quantization and higher sampling levels, obviously the number of bits which represent a certain amount of audio signal will increase a lot, which causes increase in the size of that audio file. And there comes a problem when we want to go for transmission of that signal. We need to increase the bandwidth, we need to increase the data rate and whatnot. We need to go for we need to go for a processor which can process a huge amount of data, piles of data, and that also could create a problem. And that is the reason why we need to go for compression, because ultimately all these data signal, let it be audio or video, all that we are studying is for multimedia applications. Now when multimedia applications comes, all these parameters, all these signals will come on a common platform, and there we cannot take a risk of dealing with very huge and bulk amount of data. So that is the reason why compression is must. Now International Telecommunication Union, which is short form abbreviated as ITUT, it is an international standards which specifies that how an audio signal or a digitized speech signal can be compressed and decompression can be done. Now they have several amount of standards which starts with G.7xx, which recommends that the digital signal which is used for the transmission systems, and specifically when an audio signal is converted into a digital form, and how do we go for this kind of convergence. So for that so it ensures that whenever we go for conversion of analog signal into the digital form, how do we go for the coding level? So all different kinds of codings that we used, that has been specified by this G.7xx standard. Now there are variety of standards available. Now out of which let us understand a few of the important standards here. Now, the first standard for the audio signal which is transmitted through internet, we have G.711, which use or which suggested that for conversion of A to D, we need to go for pulse code modulation. Now, when we go for this PCM, that is pulse code modulation, we need to go for there has to be an analog signal for which we need to go for 8,000 samples in a second. So when we go for 8,000 samples a second, with each sample represented by 8 bits, so here quantization level we have decided. So with that 8,000 samples in a second with 8 bit to represent one sample, we have here 64 kilobytes of data that we need to process, or we need to build a system which ensure that the processing is done or processing is carried out with a 64 kilobits per second. That has been suggested by a standard, call it as an G711. The next standard which is suggested by ITUT, that is G721, which here goes with PCM only, but an advanced kind of PCM for adaptive differential pulse code modulation. Now, obviously, with PCM, we cannot have, or we could not get higher amount of compression levels. So we go for ADPCM, where we go for finding out the differential values of the signal which we go for coding. So with that, with ADPCM, we use in G721, where we get good compression levels. And the third one or the final one here is G721, which again go for subband adaptive differential pulse code modulation, which ensures that whatever the audio signals that we get, we should divide that entire audio signal based on its the total content of frequency. Like say for example, if certain orchestra is into the playing, then it will have certain amount of different instruments playing. Now in that there will be certain which will be going for low frequency range, there will be something which will be going for high frequency rates. And if we go for PCM is going to apply the entire coding scheme for all the frequency ranges. Even that has happened with ADPCM also. But what this sub-band adaptive differential pulse code modulation, that is SB-ADPCM, suggests that when we go for division of the audio signal based on its frequency range, we will get more and more level of compression, and we can save a lot many amount of space, as well as with the bit rates also we can considerably save. And with ADPCM, with SB ADPCM, what we do is we divide the audio signal based on its frequency. So we go for certain low frequency channel and then with high frequency channel, and then we go for applying different scheme for different channel. Then last bit that we will cover here is multi-channel or Dolby 5.1 sound in DTV. Now, what exactly this Dolby 5.1 sound stands for? What it suggests is, earlier there used to be only monotonous audio signals, that one audio signal will be containing the entire picture, entire audio signal information, which what it means is, whenever recording is carried out, it is to be carried out via one microphone only, so that there will be only one signal for representing that audio signal while recording itself. But later on we realize that if we need to have a live effect of, if we sit in a concert and if we are listening to it, there has to be, like, depending upon our position where exactly we sit, there is to be a different kind of experience that we get in a live concert, and to listen back to the same, obviously there will be a different kind of effect. Now to get that effect, this kind of structure generally we follow in Dolby system, where we ensure that by considering that a certain person is sitting on a sofa set, then the recording is done in a way that like here you can see, this is how the earlier system of monochrome, where this mono channel, where at the whenever an orchestra used to play, only a single camera, only a single microphone used to keep exactly at the center. When we switch back to stereo system here, now here you can see, while recording only we keep one sound, one microphone at the left side, one microphone at the right side, and then with both those microphones we trap the signal, and then we combine those signal together in one signal, and then we transmit, so that at the receiving side we can have the effect of for left as well as right separately. Then we next type that we have is Dolby surrounding, where along with, just a minute. So a Dolby surrounding, where along with the left and right, we also get some feeling of the surrounding, where exactly the same scenario is not taking place. Then also surrounding noise also should be part of the audio recording, so that we can have that live feeling. And then the last one comes, that is with 5.1, which ensures that with Dolby, what exactly Dolby has done, Dolby has treated the entire audio frequency range in two kinds of way. Like for example, once it capture the left, right, then center, then the side of the left, the surrounding of the left, surrounding of the right, and then at LFE also it has captured, and then it ensure that for the entire frequency spectrum of that audio signal, it will go for like if it will go for processing each signal with variation in its frequency. Say for example, in an orchestra, if certain guitar is being played and certain say mridung is being played or a tabla being played, so a mridung or a tabla, those are low frequency equipments where with low frequency the amplitude levels will be very high, so obviously the signal strength will be high and that need to be processed separately, while for a guitar it's an high frequency signal, so its amplitude will be low, and if we apply similar scheme of compression for both, there it will be injustice for a guitar, because it will get very low quality from a guitar sound, while as compared to that of an mridung or for an tabla. And that is the reason why, as an instrument get changed in terms of frequency, the compression level has to be changed accordingly, and that is what exactly been done by a Dolby system. So I think this will be enough. Thank you so much. Let us see you soon for with chapter number 5 and 6, which merely focus on the multimedia communication. Thank you.